Hey everyone. So now that we've seen how to use the stitch constraint to connect specific pieces of our simulation, let's look into a actually simpler constraint, and that is the glue constraint. Now let's say I have something like this here where my geometry is supposed to be made of multiple patches, leather patches in this case, and I want to handle them as if there would be one setup. Now, on purpose, I left a gap between the pieces so that I can't use the weld constraint. The way I did that doesn't really matter, but what is interesting is I tried to pin the corners of my piece here, and for this I used a little trick. Another way of doing this, I used a bound where I fused the points on the edges, and I used a copy to points and create geometry there or boxes there to then use that as an input for my group. That's the only special thing about this. But let's now turn this into a cloth setup with the Vellum constraint cloth, and then of course a Vellum solver. And if I run this, as you might expect, oh wait a minute, I want to use the pin group in the cloth first. There it is, there's my pin group, and as you might expect it just falls down because nothing is connected. Now, like I said, a weld constraint will not work here because the points are on purpose not on top of each other. So what I could try, of course, is a Vellum stitch points. But I have a problem now, and that is that the Vellum stitch points, as you've seen before, always tries to find the closest point in the whole geometry setup, which is always itself. So it doesn't necessarily look for other geometry unless, or other pieces better, unless we specifically say between which pieces the connection should happen. The problem we have here is that, okay, we have many pieces with many other pieces it could connect to. So in a case like that with many pieces and not a specific connection I want to specifically control, but more like connect everything with everything, this isn't really helpful because there's no way for me to tell the stitch constraint to always connect to the closest piece. And this is where the glue constraint comes in. We will use the glue constraint for other things later when we use dynamic constraints, because as the name suggests, it can be used to glue things together. But by itself, you can see what it does. It finds the closest object that is not the same piece, but still a cloth object, and then, or part of the input at least, and then connects it. And as you might imagine when you look at this actually has a search distance. So it has a built-in search distance. This is what it's made for. It finds the closest position, or actually the closest point, to be more precise, on another piece. And this is one of the disadvantages of this technique. It only connects to existing points. So it doesn't work like we've seen with a stitch point, where it connects to the closest surface point, but only other points, which in this case doesn't matter at all, but in other cases can be a disadvantage. Now, the cool thing is I don't have to do anything. It now found the connection by itself. And if I run this now, you can see everything stays together. The cool thing here is, by the way, I'm not sure if we've done this before, but we can actually use the constraints as an output. As you can see here, they are animated or they are simulated, and we can take them as an output. And as long as we give the glue constraint a group name here under, because it only has one constraint setup or connection, which is the stretch. For some reason, it's always called stretch, but I can change the output group to not be called stretch because we already have a stretch group coming from the cloth constraint. So let's call it glue. And this way we can find it again later on when it comes out of our constraint output. And there it is, glue. And let's make sure we delete everything else. And we can now use that as an additional geometry. For example, with the sweep, we could thicken this up, or polywire would work as well. But the sweep is the more modern way of doing this. So if I lower the radius here to maybe something like this, and then turn on the caps, something like this. And now it looks a little bit like stitches. And if I combine this now with my geometry, as you can see, it looks as if there's a connection between them because those are the constraints. Let's actually change the color to maybe something darker. It's easier to see then. There you go. And then you can see this way, we can really simulate something like stitches directly for pieces that are not directly on top of each other. Otherwise, we could use a weld. Okay, so this is really handy for a case like that. Another case you could run into is when you have more like three-dimensional pieces which you want to connect. So it doesn't only work with flat pieces. So let's say I have here a sphere that I scatter other spheres on top, and then I give them colors and turn them into cloth. And then I have here a collision box, and I turned on my ground plane for the Vellum simulation. And then this way it looks like this. It falls down, and of course, because the balloons, or how we want to call that, are not connected in any way, they just fly around randomly. This is, keep in mind this is a Vellum simulation, so each ball is basically an empty shell that is deforming. So if you only need spheres that are not deforming, you wouldn't use Vellum for this, you would probably use RBD or something, but this is just an example, because what we can now use is again a Vellum glue constraint. Just stick it in and it will automatically find the connection between the points, not the surfaces, but the points. So if you look closely, it's a bit hard to see. You can see that the connections are only between points. And now those balloons, let's call them, are connected to each other, which means, of course, that the behavior will change. And there you go. They stick together as one. Of course, they implode because, they have no rigidness to them, but they are at least connected. So if you just need something simple where, just things that are close to each other are connected, then the glue constraint is a pretty helpful constraint and easy to understand. For more specific connections with a bit more control, the stitch constraint is better. But another thing that the glue constraint can be used for that we will look later at is, like the name suggests, it can actually be used as a dynamic constraint, not only before the simulation like we do now, but during the simulation, so that the connection starts to connect when objects get closer to each other. This is something we will look into later on, and this is when we will see the glue constraint again, but for now you can also use it as a start constraint. So I hope this is helpful. Thanks very much and see you later. Cheers.